Chapter 3: How to Set Up Your Local AI System. Introduction from Philosophy to Practice. In Chapters 1 and 2, we explored why sovereignty matters, the hidden costs of cloud dependency, the legal risks, the spiritual fragmentation, and why control determines whether AI serves you or exploits you. Now it's time for action. This chapter is where theory becomes reality. I'll walk you through preparing your hardware for a clean install, which is the critical first step, creating a bootable USB with Linux Mint as your gateway to sovereignty, installing Linux from scratch step by step with no technical expertise required, understanding why SSD matters more than you think and HDD won't work, and setting up LM Studio for your first local AI conversation. This takes approximately 2 to 3 hours total on a typical computer. Most people overestimate how difficult this is because they've never done it before, not because it's actually hard. If you can install an app on your phone, you can do this. Let's begin. Section 3.1: Hardware Preparation Checklist before you start. What you need, the absolute minimum. Here's what you need to get started. Computer. Any PC from the last 10 years with Intel Core i5 or AMD Ryzen 5 or better will work. Most computers are compatible. RAM at least 8 GB, but 16 GB or more is recommended for serious AI work. Check Chapter 2, Section 3 if you're unsure about your current setup. SSD storage. The system must be on SSD because HDD will be too slow. Hard disk drives are unacceptable for the system drive. USB flash drive, minimum 8 GB, but 16 GB is recommended to create the bootable installer. Any spare USB stick works fine. Internet connection, needed for downloading Linux Mint, which is about 2.5 GB file, and AI software later. Wired connection is preferred, but Wi-Fi is acceptable. What you need, recommended for full sovereignty. If you're serious about local AI sovereignty and not just experimenting, dedicated hardware means no personal data stored on this machine. Use a spare computer or new build or separate drive from your main system. SSD size, more space means more models can be stored. 500 GB minimum for system drive is recommended. 1 TB or more is ideal. RAM upgrade, 32 GB or more, enables larger, smarter models. Encrypted external SSD for long-term memory storage. Get a 500 GB to 1 TB USB-C external drive. If you plan store your model weights there too. My actual hardware setup for reference. I want to show you real configuration of my Strix Halo so you understand what's possible at different price points. My regular system is still running on Windows 11, which I get with new Strix Halo machine. I use it for Comfy UI, Amuse, some additional productivity tools, playing games, or for whatever software, which is still not compatible with Linux for now. Windows has his own drive, 2 TB Gen 4 NVMe SSD in full speed for electrical lanes. The system disk is encrypted by VeraCrypt for extra layer of protection. I personally prefer using Linux, but complete transition is easy to say, harder to be done. Not everything on Linux works good, or at all, and Strix Halo is still new machine concept. First generation of AMD APU. In my view, Linux is future. Windows is becoming obsolete for multiple reasons. But for now, I am not able to get rid of it completely. And for this reason, I use 2 separate SSDs. My separate AI system running on Linux Mint, which have a 250 GB Gen 3 NVMe SSD. My Strix Halo have this secondary NVMe slot running in GEN4, but with only 1 electrical lane. Speed is because of this reduced to GEN3 NVMe SSD, but even with this limit, it is still 3 times faster than older SATA SSD. I reuse this drive from my older gaming laptop, and it works with no issues. This drive holds Linux Mint installation, system tools, and LM Studio. This is my separate workspace for agentic AI. Because this disk have only 250 GB of space, I don't use it for storing huge LLM files directly. For large models and agentic memory storage, I use external USB-C SATA SSD with 2 TB dedicated to Linux. A few years ago, I buy this 4 TB SATA SSD, and I am glad I did that. Using HDD for moving huge LLM files or loading them into RAM takes with HDD literally eternity. This external disk is encrypted with LUKS. Never leave your agent long-term memory on not encrypted drives. Key points about my setup: First, dual drive approach, Windows on one drive, Linux on separate drive. Plus extra disk encrypted at disk level, both different unlock codes. Physically separated drives, not dual boot on same disk. Second, reuse existing hardware. The 250GB Gen 3 SSD came from an older laptop I upgraded. Don't throw away old parts. Third, optimal system drive size is about 500GB, which is perfect spot for Linux plus models. I use 250GB, but would recommend 500GB if starting fresh. Fourth, external storage for big files. Large LLM models from 70 to 100GB can live on external SSD to save internal space. This approach is more flexible than clean install alone. You keep your Windows setup intact while having a completely separate sovereign AI environment. When you shut down Linux, there's no access from Windows to the Linux drive, complete separation by hardware design. The critical warning: clean install required for agentic systems. Before we proceed, I need to be absolutely clear about something from Chapter 1. If you plan to use agentic AI systems, and not just LM Studio Chat, this machine or this drive must have no personal data on it before you start. Your agent will have full access to everything on the disk or drive. Personal data belongs elsewhere: your phone, your primary Windows, or better Linux computer on separate drive. This becomes a sovereign workspace only. You have three options for achieving this. Option A is separate physical drive, where Linux runs on different drive than personal files like my setup above. This is recommended because it gives complete hardware separation and keeps Windows intact. Option B is clean install on whole computer, where you wipe entire computer data and install Linux from scratch. Good for dedicated AI machine, but you cannot use it for anything else. If you have only one good enough computer for AI, running two separate disks, two OS systems are preferable. Not everybody can afford having a separate machine, which is worth of thousands of dollars, just for AI agent. Option C is LM Studio only on regular system, where you don't wipe anything, just run LM Studio without agent access. This works if you're not ready for full sovereignty setup yet. If you choose option C because you're not ready for clean install or separate drive, use LM Studio only with no full system access required. Install on regular Windows or Linux without wiping personal files. Accept the trade-off: less capability, more safety. Choose according to your needs, but make it consciously, not accidentally. Budget-friendly approach: use what you have first. Before you buy new hardware, check what you already own. SSD, even older SATA SSD from 3 to 5-year-old laptop or computer works fine for Linux system drive. Look for upgrade parts from older machines or used drives. RAM, DDR4 or DDR5 modules, often compatible across multiple systems. Check compatibility on CPU or CPUZ website before buying. USB drive: any 8GB plus USB stick can be cheap, doesn't need to be fast. Old flash drives in desk drawers work fine. External storage: HDD is fine for cold storage of large model files, but if you try using it as hot storage, expect loading to be really slow. Don't even try running models from HDD directly if you don't have eternity to spend waiting. The philosophy: you don't need everything new. Start with what you have. First, reuse old SSD from previous laptop upgrade as Linux system drive. About 50 to 100GB usable is enough for OS plus small models. Second, add larger external SSD for big model files like 70 to 100GB models stored externally. Third, upgrade to new hardware later when you know this is the right path. This saves money and reduces e-waste. My 250GB Gen 3 drive was just sitting in my old laptop, but works perfectly as a Linux AI system in Strix Halo. Don't spend money on unnecessary things you don't actually need. Check your hardware before starting. Let's verify you have what you need. Step 1. Check RAM, which takes 2 minutes. On Windows, press Ctrl-Shift-Escape to open Task Manager. Click Performance tab, then click Memory. Look at top right corner, which shows your total RAM, like 16.0 GB. Write this number down, you'll need it for Chapter 4. On Mac, click Apple logo in top left, select about this Mac. You'll see memory listed like 16 GB 3200 MHz DDR4. Write this number down. On Linux, if you're already running it, open Terminal with Ctrl-Alt-T. Type free-H. Look for the total column under mem row. Or for more comfortable checking system parameters, download free app called Mission Center. Step 2. Check current storage type to see SSD versus HDD. On Windows, press Windows key, type defragment and optimize drives, then open it. You'll see your drives listed with media type column. Look for solid-state drive or hard disk drive. If it says HDD, you must upgrade to SSD before proceeding. On Mac, click Apple logo about this Mac's storage tab. Usually Macs have SSD already, unless very old model. If unsure, search your Mac's exact model online for storage type. Step 3. Verify internet connection speed. You'll download Linux Mint, which is about 2.5 gigabytes. This takes time depending on your connection. At 10 Mbps internet speed, download takes about 34 minutes. At 100 Mbps, it takes 3 to 4 minutes. Tip: use wired Ethernet connection if possible, more stable than Wi-Fi for large downloads. You get less EMF radiation as bonus. Step 4. Gather your USB flash drive. You need minimum capacity of 8 gigabytes, which can hold the Linux Mint ISO file. Recommended is 16 gigabytes or more for more room and faster speeds. Type should be USB 3.0 or higher preferred, but it's backward compatible with older ports. Important: all data on this USB stick will be erased when we create the bootable installer. If you have files saved here, back them up first. Section 3.2. Why SSD is non-negotiable and HDD won't work. The hard truth: AI needs speed. Here's something non-technical people don't understand until they try it with slow storage. Local AI requires fast storage, and HDDs are too slow. Let me explain why, using a simple analogy. SSD versus HDD, how they work. Traditional hard disk drive, or HDD, works like this: spinning magnetic disk with read-write head that moves physically. Speed is about 100 to 200 megabytes per second sequential read. Real-world feeling is slow, like walking through mud when loading programs. The problem: AI models are large files from 5 to 100 gigabytes that must load into RAM quickly. An HDD can't keep up. You'll wait minutes for model loading instead of seconds. Solid-state drive, or SSD, works like this: flash memory chips with no moving parts. Speed is about 500 megabytes per second for SATA SSD to 7,000 plus megabytes per second for high-end NVMe SSD Gen4. Real-world feeling is fast, like a sports car compared to the HDD's tractor. The advantage: AI models load in seconds instead of minutes. System remains responsive during inference. No frustrating wait times. The maths: how much faster is SSD? Let me show you what this means for your actual experience with local AI. Loading a 25 gigabyte model into RAM takes about 4 to 6 minutes on HDD, 30 seconds on SATA SSD, and 10 seconds on NVMe SSD Gen4. Starting LM Studio application takes 30 to 60 seconds on HDD, 5 to 10 seconds on SATA SSD, and 2 to 3 seconds on NVMe SSD Gen4. Opening large PDF document takes 15 to 30 seconds on HDD, 3 to 5 seconds on SATA SSD, and 1 second on NVMe SSD Gen4. Searching through 10,000 files takes 10 to 20 minutes on HDD, 2 to 3 minutes on SATA SSD, and 30 seconds on NVMe SSD Gen4. This isn't just about convenience. This is about whether the system feels usable or frustrating. Minimum requirements: what's acceptable? HDD traditional, no, too slow, which will make AI unusable. SATA SSD, yes, as minimum requirement, good enough for all local AI workloads. NVMe SSD Gen 3 or better Gen4. Best choice. Ideal performance, worth the extra cost if budget allows. For additional money to buying SSD over HDD, you get 10 to 20 times speed improvement. The choice is obvious if you're serious about AI work. My recommendation: start with SATA SSD. If budget is tight, get SATA SSD with 500 gigabytes to 1 terabyte, which is good enough for everything. Later upgrade to NVMe when you can afford it. If budget allows, get NVMe SSD with 1 terabyte or more for best performance from the start. Whatever you choose, make it an SSD. Never HDD for system drive running AI workloads. This is non-negotiable. What if my computer only has HDD? If your current computer only has a traditional hard disk drive, option 1, upgrade before starting, which is recommended. Buy SATA SSD, replace HDD with new SSD. This requires opening computer case, but can be done at home or by local shop for some extra buck. Proceed with Linux installation on new SSD. Old HDD becomes secondary cold storage for non-AI files if you need extra space. Option 2, try using external SSD as temporary solution. Buy USB-C external SSD, install Linux to external drive, boot from USB external drive every time. Slower than internal, but still better than HDD. Option 3, don't start yet. Acknowledge current hardware isn't ready for AI work. Save money for upgrade, then proceed when prepared. Better to wait than start with frustratingly slow system. If you will be forced to spend eternity on every step from start, you will probably just give up. Section 3.3, Creating Bootable USB with Linux Mint Step-by-Step. Why Linux Mint? I recommend Linux Mint as your starting point because, first, familiar interface, looks and feels like Windows with minimal learning curve. Second, stable and reliable, based on Ubuntu LTS, which is long-term support, won't break unexpectedly. Third, large community, thousands of tutorials, forums, and support resources available. Fourth, hardware compatibility, works well with most computer hardware from last 10+ years. Fifth, privacy-focused, no telemetry, no data collection, you control everything. Other Linux distributions exist like Ubuntu, Fedora, Pop! OS, but Mint is the best starting point for Windows users transitioning to sovereignty-focused systems. I understand that most people start on Windows, I am no exception. But Windows has shifted over years too far away from personal computer promise to big tech corporation cloud data gold mine, and growing number of people seeing this shift as not acceptable anymore. Downloading Linux Mint ISO file. Step 1, go to official website. Open your web browser and navigate to linuxmint.com/download. Important, always download from the official website only. Third-party downloads may be compromised or modified. Step 2, choose the right edition. You'll see 3 editions available. Cinnamon is for most users with modern interface. Start here as best choice. Mate is for older hardware with classic interface. Only use if computer is 10+ years old. XFCE is for very low resource systems with 4 GB RAM or less, only for minimum spec machines. For most people, download Cinnamon Edition. It's the flagship with the best interface and support. Step 3, select Mirror Server. Click on a mirror link near your geographic location for faster download speed. Example, if you're in Europe, choose a European mirror server. The ISO file is about 2.5 GB. Expect 5 to 10 minutes with typical broadband. Step 4, verify download, which is critical for security. After downloading, you'll have a file named something like linuxmint-21.3-cinnamon-64bit.iso, which is about 2.5 GB. Go back to download page and find the checksum or hash verification section. Calculate your downloaded file's hash and compare with official value. If they match, file is authentic, not tampered with. If they don't match, delete file and re-download. Something went wrong. Always verify downloads from official sources before using them. Creating bootable USB with Rufus or Balena Etcher. Option A, using Rufus, which is recommended for Windows users. Download Rufus at Rufus, i.e. free open source. Preparation steps. Insert your USB flash drive into computer. Download and run rufus.exe, no installation required. In Rufus interface, device should show your USB drive automatically. Click Select, then choose the Linux Mint ISO file you downloaded. Leave other settings at defaults, which are usually correct for most systems. Click Start button. You'll see warning that all data on USB will be erased. Confirm to proceed, which takes about 10 to 20 minutes for writing process. When complete, Rufus shows ready message. Safely eject USB drive from computer. Option B, using Balena Etcher for Windows, Mac, or Linux users. Download Etcher at Balena, eo/Etcher, free cross-platform. Insert your USB flash drive into computer. Download and install Balena Etcher. Launch application, you'll see 3 buttons. Flash from file to choose Linux Mint ISO, select Target to choose your USB drive and flash. To start writing process, which takes 10 to 20 minutes. Wait for completion, then safely eject USB drive. Verifying bootable USB created successfully. After creating the bootable USB, reboot your computer with USB drive inserted. Enter BIOS or UEFI setup, which is usually F2, F10, or Del key during startup. Set USB drive as first boot device in boot order. Save changes and restart. You should see Linux Mint's boot menu appear. If it shows success, your USB is ready for installation. If nothing happens, try creating USB again or test different USB port. Section 3.4, Installing Linux Mint Step-by-Step Walkthrough. Before installation, critical preparations. Backup important data. Because we're doing a clean install, always backup files you need elsewhere first. This process will erase everything on the target drive. Plug in your computer. If using laptop, keep it plugged into power during installation. Don't rely on batteries. Disconnect from internet temporarily. For initial setup, disconnect Wi-Fi or Ethernet. We'll reconnect after Linux is installed to avoid automatic updates interrupting the process. Starting the installation process. Step 1. Boot from USB drive. Insert bootable USB into computer. Restart your computer completely. During startup, press BIOS or UEFI access key repeatedly. Dell uses F2 or F12. HP uses F10 or Escape. Lenovo uses F1, F2 or Enter. Asus uses F2 or Dell. Acer uses F2 or Dell. If unsure, Google your computer model plus BIOS access key. In BIOS or UEFI setup, navigate to Boot tab using arrow keys. Change boot order so USB drive is first option. Save changes and exit, which is usually F10. Computer restarts, you should see Linux Mint's purple boot screen. Select Start Linux Mint from menu and press Enter. You're now running Linux from the USB stick without installing anything yet. This is called a live environment. You can test Linux before committing to installation. Step 2. Try before installing, which is recommended. Before committing to installation, spend about 10 minutes exploring. Click the menu button in bottom left corner, which is similar to Windows Start menu. Open web browser and check if your Wi-Fi or Ethernet works. Test audio by playing a sample sound. Check if keyboard shortcuts work as expected. If everything looks good and hardware is recognized, proceed with installation. If critical hardware doesn't work like Wi-Fi or sound, you may need to troubleshoot before proceeding. Step 3. Launch installer. On your desktop, double-click icon, Install Linux Mint. Welcome screen appears, choose your language, then click Continue. Keyboard layout, choose your keyboard type, which is usually correct automatically, then click Continue. When asked about third-party software, check the box for media codecs and proprietary drivers. This ensures support for Wi-Fi, graphics, sound out of the box. Click Continue. Important, installation type screen, this is critical. Partitioning, where to install Linux critical decision. This is where most people make mistakes. Let me be crystal clear about your options. This is the most important choice in the entire installation process. Option A, erase this disk and install Linux Mint, which is recommended for sovereignty work. Use this if you're installing on a separate physical drive from your personal files, like my setup with Windows on 2 TB drive 1, Linux on 250 GB drive 2. This drive will be your sovereign AI workspace only, no personal data ever stored here. Personal life happens on completely different hardware, like your main Windows computer or phone. What it does, wipes only this drive, which is the one you're installing to, installs Linux from scratch. If this is a separate drive from your Windows system, your Windows files remain untouched on the other drive. This is my recommended approach because complete hardware separation equals maximum security, no risk of accidental access to personal data. Your agent has clean access to everything on this drive only, and you can still boot into Windows on the other drive when needed via BIOS boot selection. How it works in practice. Enter BIOS during startup with F2, F10, or Del key, depends on your motherboard. Select which physical drive to boot from, like Windows Drive or Linux Drive. When booted into Linux, you can't access Windows Drive unless you explicitly mount it. When booted into Windows, you can't see Linux Drive files without special software. This is the clean install approach, but on a separate drive instead of wiping your main computer. Your personal data stays safe on Drive 1, while your AI workspace lives clean on Drive 2. Option B, dual boot with Windows plus Linux on same drive, not recommended for sovereignty. Use this if you're experienced with partitioning and understand the risks, or you don't have a separate drive available. But it's not recommended for sovereignty-focused users. Why I don't recommend dual boot. Both operating systems live on same physical disk, which makes complete separation harder to maintain. Risk of accidental cross-access between Windows and Linux partitions. More complex to configure securely because agent could potentially access both environments. If you mess up partitioning, you could lose both OS installations. Only choose this if you have no other option and understand the security implications. For true sovereignty, separate physical drives are superior. Option C, external drive installation, which is good for testing but slower performance. Use this if you want maximum portability to take your sovereign system anywhere, or USB connection is slower than internal SSD, but still much faster than HDD, or slightly more complex to boot from external drive on different computers. Performance note. External NVMe via USB-C or 3.0 is about 80% as fast as internal, acceptable for most AI workloads, especially with Gen 3 drives like my 250GB setup. My specific recommendation based on your situation, if you have separate SSD from old laptop drive or spare drive, install Linux on that drive using Erase this disk option, best choice. If you only have one internal drive with Windows, consider external SSD installation or buy affordable 500GB SATA NVMe for separate install. If you don't want to install anything yet, use LM Studio only with no system wipe needed. If you choose the separate drive approach, which is my recommendation, power down computer completely and unplug power cable. Install Linux drive in second M2 slot or use USB to NVMe adapter for external installation. After you finish new hardware installation, plug back power cable and start computer. Reboot from Linux installer USB. During installation, when asked installation type, select Erase Disk and install Linux Mint, but critical warnings. Make absolutely sure you select the correct drive, which is the one with no personal data. Look at drive sizes. My 250GB Linux drive versus 2TB Windows drive made this obvious. Double check before clicking continue. There's no undo after this step. If you are not confident enough to choose right drive, simply physically remove Windows drive and put it back after Linux installation is done. Complete installation. Windows on other drive remains completely untouched. Critical warning, always verify which drive you're erasing before confirming. Look at drive sizes and names to identify them correctly. If you accidentally erase the wrong drive, your personal data is gone forever with no recovery possible. When in doubt, stop, boot into BIOS, check which drives are present, then restart installation with fresh USB. Better to be slow and safe than fast and regretful. You can choose Lux protection of disk during installation, which is full encryption of your disk, not just Linux installation. Recommended. Continuing installation after choosing Erase Disk on correct drive. Confirmation screen. You'll see warning that all data will be erased. If this is clean hardware or you've backed up files you need, click Continue. This erases everything, no going back after confirmation. Installation begins, which takes 15 to 45 minutes, depending on your SSD speed. You'll see progress bar and messages about copying files, installing system. During installation, you'll be asked for your location for time zone, click on map or type city name. Keyboard layout confirmation, which is usually already correct. User account setup, where your name is what you want displayed. Computer's name defaults are fine and can change later. Username is your login name with no spaces and lowercase letters. Password is strong password you'll remember, so write it down securely. Or better, keep it in your mind only. Option to log in automatically or require my password to log in. For security, choose require password. Wait for completion of installation. First boot after installation completes. When installation finishes, you'll see message, installation complete. Click Restart Now button. You'll see instruction. Please remove the installation medium, which is USB drive, and press Enter. Remove USB stick, then press Enter on keyboard. Computer restarts normally into your fresh Linux Mint system. First login screen appears. enter username and password you created earlier. If instead of Linux, Windows appears, restart again and check BIOS boot setting. Decide which system you use more often and put it in first boot starting line. That system will start automatically, and if you want to choose second one, you need to change boot option permanently or just one-time fast boot secondary system. This can look too technical at start, but after some practice, you will be doing it without any issues. BIOS seems intimidating at start, but it is same with Linux. Congratulations! You now have a completely clean Linux installation with no personal data anywhere on the disk. This is exactly what sovereignty-focused AI work requires. Post-installation, essential initial setup takes 30 minutes. After booting into your fresh system for the first time, Step 1. Connect to Internet. Click network icon in bottom right corner of screen, which looks like Wi-Fi signal or computer monitor. Select your Wi-Fi network from list and enter password or plug in Ethernet cable. Wait about 10 seconds for connection established message. Test by opening web browser and visiting linuxmint.com if page loads, success. If you're disconnected during installation, reconnect now before proceeding with updates. Step 2. System updates first time. Open Software Updater from menu, which is search for it in bottom left menu. Click Check for Updates button. You'll see list of available security patches and improvements. Click Install Updates. This may take 10 to 30 minutes depending on your connection speed. Important, do not skip this step. Security updates are critical for protecting your system from vulnerabilities, and you will need some additional drives for GPU or other hardware. Not everything is automatically installed at OS installation. After updates complete, you may be prompted to restart the computer. Do so if requested. Step 3. Install additional drivers if needed. Open Driver Manager from menu. If it detects proprietary drivers needed for your hardware, which is common with NVIDIA graphics cards, recommended driver will show as recommended. Click to install, then restart computer when prompted. Most systems won't need this step if you selected media codecs during installation, but check anyway to prevent possible issues later. Step 4. Install essential software. Open Software Manager, which is like an app store, and search for or install these essentials. LM Studio for local AI model management and chat must install as Chapter 3 continuation. Firefox comes pre-installed as web browser with privacy extensions, enhance with uBlock Origin. GIMP or Krita for image editing if needed for course creation, optional. LibreOffice comes pre-installed for document editing compatible with Word and Excel. VeraCrypt is recommended for extra security as full disk encryption tool. If LM Studio doesn't appear in Software Manager, open manually browser at LM Studio. AI. Section 3.5. Installing LM Studio, your first local AI. What is LM Studio? LM Studio is a free, open-source application that lets you download AI models easily without command line expertise required, run them locally on your hardware, and chat with them privately. Nothing leaves your computer by default, only if you choose LM Link enabled or connect by some other additional service to cloud. You can do this, but I cannot recommend it. If your goal is privacy, don't open unnecessary doors. It's the perfect starting point for local AI sovereignty, and it works identically whether you're on Windows or Linux. Step 1. Download LM Studio. Open Firefox or any web browser. Navigate to LM Studio AI. Click Download button in top right corner. Choose version for your operating system. If you just installed Linux Mint, select Linux version. Download will start automatically, which is about 1 GB file. Note, LM Studio is free and open source. There's no paid tier or subscription required. This is software that belongs to you, not a company. Step 2. Install LM Studio on Linux. Linux installation differs from Windows, no double-click installer. Here's how to set it up. Using app image, which is simplest method. Navigate to your Downloads folder in File Manager. Find the downloaded file, lmstudio.*.appimage. Right-click on File, select Properties, then Permissions tab. Check box, allow executing file as program. Double-click the app image file. It launches immediately with no installation needed. First time you run it, LM Studio creates its configuration folder automatically in your home directory. Step 3. First launch, configure LM Studio. When LM Studio opens for the first time, you'll see Welcome screen with options on the left sidebar. Click Settings icon, which is gear symbol, in bottom left corner. In Settings, configure these critical preferences. Model directory, where you choose where to store AI models. Default location is fine, or choose external SSD if you have one. GPU offload, if your computer has dedicated graphics card, set to auto for now. LM Studio will optimize automatically. If you don't have GPU, or your GPU is really old below 2 GB of RAM, use CPU only. Context length starts with default, which is usually 4096 or 8192 tokens, can increase later up to your hardware's capability. Chapter 5 covers long context optimization. Close settings. Configuration is saved automatically. Step 4, download your first model. Now the exciting part, getting your first AI model. Search for models. Click search icon, which is magnifying glass in left sidebar. In search bar, type one of these model names based on your RAM. My favorite is QN family, but you can choose anything else you want. If you have 8 to 16 gigabytes RAM, type QN 3.54B. If you have 16 to 32 gigabytes RAM, type QN 3.59B. If you have 32 to 64 gigabytes RAM, type QN 3.535B, a 3B, which is recommended starting point. If you have 64 plus gigabytes RAM, type QN 3.122B, a 10B. LM Studio CPU driver settings loads LLM into system RAM, and all will be processed by CPU only. This is usable for people with patience, but it can be very slow. Much better is having a GPU RAM, which is multiple times faster. But GPUs are very expensive, power-hungry, and have strictly limited RAM gigabyte limits. Even if you buy 16 GB GPU and model doesn't fully fit in, you get still speed boost for offloading some model weights. Only if model fully fits in, you get very high speed. Because RAM and RAM copy data between itself, everything drastically slows down. But what doesn't slow down is your energy bill from all day long screaming GPU fans, trying to cool down hundreds of watts going trough its processor. This is limited approach for local AI, because small models are not much capable as agents, and GPUs are hungry in multiple ways. Your only option here is to scale GPUs, which will kick your banking account into stomach, and same time your energy bills into stratosphere. For seriously interested people in AI, I advise to consider an APU computer like my Strix Halo, which fixes both of these issues same time. My system has 128 GB shared memory, and I can set it manually from 32 GB to RAM and 96 GB to VRAM, to one-sided 128 GB fully to system RAM. But for balanced performance, I am using auto mode, which is setting 64 GB to both RAM and VRAM. In this mode, RAM can tap under pressure into additional 22 GB of RAM, or more interestingly, GPU can tap into additional 32 GB from system RAM. It can sound complicated for beginners, but it is actually very simple. LLMs are taping in both pools of shared memory same time, and you can't just put 128 GB to VRAM and ignore everything else. System OS and CPU need some space to breathe too, and if you choke them, whole system freezes. As you can clearly see, normal computers with GPUs cannot compete with this new generation of AI PCs. Cost of APU is not low, but return is very high compared to regular GPU. Power draw is very low, around 100 watt under full pressure. My machine can literally run all day long, and I don't care. I put 2 extra 0.15 ampere PC fans on upper ventilation air draw, and mostly doesn't even hear inside fans running much at all. At LM Studio Model Search, you'll see search results. Look for these indicators. Check for GGUF format, which is standard for local AI. Look for quantization level like Q40, Q4KM, or Q80 recommended. Lower numbers mean smaller file, faster but less precise. Higher numbers mean larger file, slower but more accurate. Avoid Q2 or Q3 versions because they're too lossy, and FP16 because it's too large and slow. Click on a model between Q4 and Q8 that matches your hardware limitations from the list. Download selected model. On right side of screen, you'll see download options with different file sizes. Example for 35B, a 3B model. Q40, which is about 20 GB, gives good balance. Q4KM, which is about 21 GB, gives slightly better quality. Q80, which is about 40 GB, gives near lossless, best quality if you have space, and can tolerate slower work speed. Click the download button, which is downward arrow icon, next to your chosen quantization. Download progress appears at edge of screen in minutes, depending on file size and your internet speed, of course. Models download sometimes freezes, check it from time to time, and if file sizes doesn't move, press pause, then continue. Be careful not to press cancel or whole file gets scraped. When complete, model moves from Download tab to Models tab. Model Selection Guide. Don't worry if you're not sure which model to pick yet. Here's my recommendation for first-time users. If you have 8 to 16 GB RAM, download QN 3.54B with Q4KM quantization, about 5 GB file size because it's fast, reliable, good for testing. If you have 16 to 32 GB RAM, download QN 3.59B with Q4KM, about 9 GB because it gives better reasoning, still fast. If you have 32 to 64 GB RAM, download QN 3.535B, a 3B with Q4KM, about 21 GB for medium reasoning with speed, which is good agentic capability. If you have 64 plus GB RAM, download QN 3.122B, a 10B with Q40, 80 GB for high agentic intelligence available. At this moment in early 2026, maximum for us mortals, without unlimited golden MasterCards. Note, you can download multiple models later and switch between them. Start with one model for your first conversation, then expand as you learn what works best for you. Don't use more than one model at a time if you don't have enough resources. Special AI computers like my Strix Halo are exception. I can use easily one bigger model, and same time in parallel another smaller. I can, but it will cost me a reduced speed for both if they work simultaneously on different tasks. Most of the time, one model is enough and completely acceptable. Working with more agents running same time is for higher grade hardware and experienced users. Don't push yourself and learn basics first. Step 5. Have your first local conversation. Now comes the moment, your first interaction with your personal AI. Click chat icon, which is speech bubble in left sidebar. At top of screen, click drop-down menu showing no model loaded. Select the model you just downloaded from list. Don't try setting parameters for now if you are newbie. At start, those things doesn't make much sense before people learn more. You'll see model loading progress bar, which takes 5 to 30 seconds, depending on SSD speed and model size. Wait for it to complete before typing anything. When model is loaded, chat interface shows empty message box at bottom. Type your first question like "Who are you?" or "What can you do?" Press enter. Watch as the AI begins generating response word by word. You'll see text appearing in real time, which is the generation process. Wait for complete response, which takes 10 to 30 seconds for typical answers. If response seems cut off, press enter again and type continue. Try asking a follow-up question to test memory within this conversation like, "Earlier you said X, can you elaborate?" It should remember context from this session. Notice what feels different compared to cloud AI. Nothing left your computer, complete privacy. Response speed may be slower than cloud, but that's acceptable trade-off for privacy. You control the conversation completely, no filters blocking topics. If you still encounter some programmed topic blocker, you can try Ask Differently or download Heretic LLM version. But do it at your own risk. These models are highly modified and can be unstable or even dangerous. I cannot recommend it for agentic work. Try it only for basic LM Studio use without system access. Troubleshooting common first-time issues. Issue 1. Model won't load error. Cause is not enough RAM for selected model size. Solution: download smaller quantization like Q4 instead of Q8 or smaller model entirely. Issue 2. Slow response times. Cause is HDD storage, insufficient GPU offload, too many background programs. Solution: ensure SSD is being used. Close other applications. Check GPU settings in LM Studio. Check in system monitoring if model uses your GPU RAM and where processing occurs when he works. It can be a little tricky set up right parameters if your model doesn't fit your GPU entirely. If you have too much difficulty and nothing works right, use CPU only and ask your AI where you are doing mistake. Oh yes, use your personal AI immediately. You don't need to beg Big Brother Google for anything anymore. Issue 3. Chat interface frozen after selecting model. Cause is model file may be corrupted or incomplete download. Solution: delete and re-download the model from Search tab. Section 3.6. Your first week plan: building sovereignty gradually. Now that you have local AI running on your sovereign system, here's what to do next. Organized as a manageable progression over 1 week. Day 1. Complete this chapter with Linux installation plus LM Studio setup. Purpose is foundation established. Day 2. Have several conversations with your AI. Test capabilities and limitations. Purpose is build familiarity. Discover what it can do. Day 3. Research about long-term memory systems for your future agentic assistant. Purpose is understand why persistent memory matters. Day 4. Explore different models in LM Studio. Download one alternative model to compare. Purpose is learn which model style suits your needs best. Day 5. Reflect on differences between local AI and cloud AI experiences. Purpose is solidify understanding of sovereignty benefits. Day 6. Decide if you're ready for full agentic system with long-term memory setup or stay with LM Studio only. Purpose is make informed choice based on your comfort level. Day 7. If ready, begin Chapter 4. If not, continue practicing with current setup. Progress at your pace, no pressure. The key principle: sovereignty is a practice, not a destination. Here's what I want you to understand before finishing this chapter. You don't need to do everything perfectly on day 1. Sovereignty is built through consistent practice over time. Some people start with LM Studio only and gradually work up to full agentic systems. Best thing on starting slowly like this: ask AI to teach you what you don't know and don't understand. It's right in front of you waiting. Personal teacher 24/7 for anything and anyone. Ask him about LM Studio configurations and learn it one by one. And trust me, it will take you some time to get it. It's new technology, and majority of society have absolutely zero idea how any of this really works. Take advantage and learn now whatever you want. Some dive deep immediately and never look back to cloud. Both approaches are valid. What matters is conscious choice instead of defaulting to cloud dependency, because that's how it always was. God give you your own discernment, use it. Follow your own path, not big tech con script. Your journey might look like week 1 to 2 with LM Studio only building familiarity. Month 1 to 3 start learning about long-term memory for persistent memory management and advanced settings. Month 6 full agentic system with voice pipeline and advanced workflows, full memory encrypted on external SSD. Or if you are crazy enough, you might jump straight to full implementation. Either path works as long as it's your decision based on your values and comfort level. Don't push yourself into things you fully don't understand. Autonomous Agent is very powerful. It's not just some cool tool or toy anymore. It's your foundation for safe future because robotics are coming. It's inevitable next step nobody will stop. Chapter summary: what you've accomplished. By completing this chapter, you now have prepared your hardware by checking RAM and verifying SSD is present, which is critical. Created bootable USB with Linux Mint installer, ready to deploy sovereignty-focused OS. Installed Linux from scratch, clean system, with no personal data anywhere on disk. Understood why SSD matters, because HDD creates unusably slow AI experience, non-negotiable upgrade. Selected appropriate distribution, with Linux Mint chosen for Windows-like interface and stability. Downloaded and installed LM Studio as your gateway to local AI models. Downloaded your first model, selected based on RAM capacity, covering 8 GB to 128 GB range. Had your first sovereign conversation, experiencing privacy-first AI interaction. You've moved from theory to practice. Chapter 1 explained why sovereignty matters. Chapter 2 explained what local AI is. Now you have actual working software running on hardware you control. Reflection exercise: how does it feel? Before moving to Chapter 4, take a moment to reflect. What surprised you most about having your own AI? Speed differences from cloud expectations. Privacy feeling different than expected. Something else entirely. Which part was more difficult than anticipated? Hardware preparation. Linux installation process. Model selection and downloading. First conversation experience. Are you ready for the next step with long-term memory system, or do you want to practice with LM Studio only first? Your honest answer determines whether Chapter 4 makes sense right now. There's no shame in waiting until you feel confident and comfortable. Your answers matter. They tell me where people struggle so I can provide better guidance. And they tell you where your growth edges are, what to focus on next in your sovereignty journey. You've built the foundation. Now let's make it truly yours. Sovereignty isn't a race. It's a lifelong practice that starts with conscious choices, like the one you made by following this guide and setting up local AI instead of accepting cloud dependency as inevitable. You've taken the first real step. Now let's make it permanent, private, and entirely yours. Start Chapter 4 when you're ready to continue. Your sovereign journey will continue from there. I'm giving all this basic AI knowledge for free of charge. Take what you want and use it for good. Use it in some honorable way of your choosing. Don't let big tech control your life and your destiny. Don't let fear stop you from using this powerful technology either. Learn, protect yourself, your family, and people you love with it. Learn something that you was not believing you ever can. Use AI as personal liberation. Counter big tech box thinking. This technology is here for all humanity, not just few who own insanely powerful data centers. It's here for me, and it's here for you too. Next steps of my courses are only for seriously interested people who want to learn more, deeper knowledge. For people who will say, I want full sovereignty and no half deals are enough for me. If that's you, we will see each other again.